Hello viewers, welcome to Let's CSE. Today in this video, our topic is bus architecture. Okay, in this video, we are going to learn the basic definition for what is bus, different types of bus, understanding of architectural design, and what is bus contention problem and the remedies to solve the bus contention problem. So let's start. First of all, what is bus? Okay, what is bus? In computer science, what is bus? Bus is a set of channels. Okay, set of channels. Bus is a set of channels, first point. Then it carries data and information as well as it carries control signal, very important, control signal throughout the computational system. Okay, throughout the computational system. It carries what? It carries data, also in data and information, and control signal, very important. It carries data and information and control signals throughout the computational system. Okay, so what it concludes? It communicates sorry build a communication sorry build a communication build a communication throughout the system. Okay, it is this bus which build the communication throughout the system. Because of this bus, the computer can communicate with one component with the other. Okay, suppose now the what are the types of bus? Okay, types of bus. First type is address bus, then data bus. Number 3, control signal lines, or you can say control bus. These three together are called system bus. Okay, together they are called the system bus. So what are the types of bus? Address bus, data bus, and control signal bus. Now the architectural design to understand this the working of these buses. Okay, suppose this is a processor. Okay, you can say processor or CPU. This is a microprocessor, and these are the devices. Okay, device 1, device 2, up to device n. Okay, d1, d2, dn. There can be many devices. Okay, now this address bus, what does this address bus do? Address bus gives the address to all these devices, okay. It is a unidirectional bus. Okay, address bus is a unidirectional bus. It is a unidirectional bus. Okay, this is a unidirectional bus. Okay, this bus the processor identifies the address and identifies the devices and gives address to each of these devices. Okay, devices don't identify the processor identifies the devices and gives the address to each of these devices. Okay, that's why the direction is unidirectional, from processor to all the devices. Okay, now the data bus is a bidirectional bus. Okay, data bus is a bidirectional bus. So that's why I have given the arrow in the both side. Okay, it's a bidirectional bus. Bidirectional. Okay, that means devices can give input which will be to the processor, and it can also processor also can give some data to the devices. Okay, that's why it's a bidirectional bus. Okay, now the control bus is also bidirectional. Control bus is also bidirectional. Okay, this diagram is not very much clear, but I hope you all can understand. Control bus is also a bidirectional bus. Why? Processor sends the control signal to all the devices. Okay, sends the control signal to all the devices, whether the job is done or not, and also devices send the acknowledgement signal back to the processor. That's why it has to be a bidirectional bus. Okay, so I hope you understood this part. Now, what is bus contention problem? Okay, now we'll discuss about the bus contention problem. You can take a screenshot of this one because it is very important, the basic architectural diagram of the buses. Okay, so now what is bus contention problem? Consider two devices. This is device A and this is device B. Okay, they are sending signal through the common bus, the data bus. Okay, this is the address bus. Let me write it: address bus, data bus, and control bus. Okay, these are the three buses. Suppose these devices A and device B, device A and device B are sending signal to each other through the common data bus. Okay, there may arise a situation where both the devices are sending signal to each other at the same time. As these devices are not synchronized, there may be a situation arising when both the devices sending signal to each other through the common data bus at the same time. Since these are not synchronized, the device suppose first the A will send the signal till the signal reaches to B. B will not send the signal to it. This will not happen. These are not synchronized. Devices will not wait. If situation arises that they are giving the signal to each other at the same time, then there arises a problem that's called the bus contention problem. Let us see. Suppose A and B are giving all the, as these are devices, semiconductor devices, the signals are considered as high and low. Okay, high is considered as 1 and low is considered as 0. Suppose first A is giving A to B. Okay, this is A. I am writing A as A to B. That means signal is going from A to B. 0, also B to A. This is B to A part. Okay, this is also 0. 0 and 0. Then another case can be 0 1 1 0 1 1. Okay, low low, low high, high low, high high. Okay, now in this case and this case, low low and high high, this and this, the result will overlap. We will not understand whose what signal is, whose low signal is which one. Okay, the result will overlap. So this 0 is also coming in this direction and this also this direction. The result will be overlapping. We will not be able to understand who sent the low signal, which devices send the low signal. Okay, which devices send the high signal. We will not be able to distinguish it. Okay, in these two cases they will overlap. But now in these two cases, one device is sending 0, that means low signal, and another device is sending high signal. Okay, in these two cases bus contention problem will occur. These two cases. Okay, bus 0 1 1 0, different signal. Okay, why? Suppose this is low signal, this is V minimum. Okay, voltage minimum, let us consider V minimum, and this is high signal V max. Sorry, this is low voltage this is low voltage and this is high voltage. Okay, one is high voltage, they are going through the same data bus. Now this, when these two will overlap, what will happen is equal to V max. This one, this one is high voltage and this one is low voltage. Okay, when they will overlap, the voltage will be maximum in this path. Okay, through the common data bus. Now as these are the semiconductor devices, the resistance in this kind of devices are minimum. Okay, resistance is minimum, resistance minimum. Okay, now we all know I current is equal to V by R. Okay, we all know current is V by R. If R is minimum and V is maximum, why maximum? High minus low gives us the voltage maximum. Okay, high voltage, one is sending signal 1 and another is sending signal 0. When we subtract them, we get the maximum voltage in these devices. Okay, and R is minimum, as these are the semiconductor devices. Now if in this case the current will be maximum, current will be maximum, and if this current crosses the threshold current of the devices will burn. Okay, so if this current will keep on increasing as this resistance is minimum in this case. Okay, so that's why the current will be maximum here, and if this current crosses the threshold current of the devices, then the devices will burn. This problem is called bus contention problem. Okay, I hope you all understood. If you have any query regarding this, you can comment down. I will surely solve your doubt. Okay, now what are the remedies to solve this bus contention problem? We cannot keep it keep this bus contention problem. It will be a huge problem for computing. Okay, so what are the remedies? First remedy, bus arbitration. First remedy is bus arbitration. This means bus sharing. We will share the bus. Okay. Now tri-state bus. Another remedy is tri-state bus. Another remedy is output hold buffer. Output hold buffer. This will hold the output for some time. Output hold buffer to the devices. Okay. Bus arbitration is bus sharing. There are three different ways under bus arbitration by which we share the buses in different order to speed up the communication, and many modes are there. We will discuss in the next video. Okay, different kinds of bus arbitration technique we will discuss in the next video. Tri-state bus, another remedy to solve the bus contention problem, and output hold buffer for the devices, to the devices. Okay, so this video, I hope you all understood the remedies. In this video I only discussed the mentioned the remedies. Okay, in the next video or the upcoming videos I will be discussing the I will be discussing these remedies in detail. Okay, so I hope you all understood this video. If you like the video, please like, share and subscribe my channel and press the bell icon to get notified for the next video. Okay, thank you.